In this video, we're going to study the compound joint hemostat. This mechanism is quite simple, yet useful in the medical devices industry.
This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer.
Today we're going to study the compound joint of a double hemostat that I have in my hands. This simple yet effective mechanism that allows for the instrument to get farther and then clip and then retreat makes it very useful. A regular hemostat looks like this, like scissors. One thing to note is that if you really open your hands to make the jaw angle that big, but with the compound joint, compound meaning many joints here, if you just open a fraction of the height that I opened before, you may achieve the same angle in the jaws, which makes it very useful. So this is a very useful instrument for surgeries and getting into the body and retrieving perhaps a sample or tissue. And we're going to reverse engineer this mechanism on CAD and discuss it a little bit further.
This is without a doubt the simplest mechanism that I've done in the Mental Mechanism Library. Nevertheless, it's an essential mechanism that I want you to keep in your arsenal. I suppose the hardest part about reverse engineering the hemostat was making the correct cutouts. I had to really think about which parts had to be combined and which ones had to be subtracted. I reverse engineer this using my preferred method, which is multi-body part modeling in a part file and doing assay bodies. In this part of the video, I'm going to introduce you to an intermediate level concept, which is master part modeling. So for context, there's a couple ways in which you can go about creating different items and assemblies in SOLIDWORKS, things that have moving parts within it, several components. One route is top-down modeling, which you can YouTube and look up, and the other one is master part modeling, which I'm going to show you today. Now, let me give you a couple of hints. I like to start out with context. So think about the name, master part modeling. Key part is part. So this is all going to be built in a part file. The main advantage of master part modeling, that is actually my preferred method of building assemblies and objects with moving parts, is that you'll be able to reference the other components while you're in the same sketch or different sketches, but in the same file essentially. So you don't have to go flipping back and forth between different files and reference them. So everything will be connected, if you will. But let me give you an example, because everything will be connected could be interpreted in many ways. So this is what I mean by that. So first I had the picture that I uploaded. Then I traced the outline, and this is very quick modeling that I've done here in the feature tree, so some sketches may be undefined, so please ignore that. The focus here is to understand the master part modeling methodology. So here's the sketch, which is basically the outline of the picture that was before, and then I'm going to start doing some extrusions. I'm going to extrude one body, and then I'm going to extrude the other body. Now, keyword I said, body. If you look in the feature tree, you now have two separate bodies. You can do this in SOLIDWORKS, and forgive me for all the advanced users watching this, but this is something I want to teach and make sure no one falls as I'm following and progressing teaching this methodology. You have the merge result checkbox. Now that's very important, because if you merge the result, then you're only going to have one body. And I purposely chose to not check that checkbox so I can have two separate bodies. Now, thinking down the line is because when I export this to an assembly, which I will show you, I'm not going to leave that for imagination, I'm going to show you that you need to have two bodies so you can have the motion. You can mate them, etc. Okay, so we have two bodies. We continue doing some sketches, some cuts. So I'm basically modifying the two bodies that I already have. Mirroring, offsetting using some surfaces, thickening the surfaces, combining features. Okay, let's keep on progressing. We still have the two bodies, so I'm basically making just little adjustments. I'm going to remove the sketches so we can see what's going on. I'm making cuts and minor details so the item actually looks like the one that I had in my hands. So I'm going to keep going. Notice that there's still two bodies, just making the modifications. Okay, so now what you can do is you go to something called, well, we actually have 4 bodies now, and let me clarify how that happened because I think that's important. So we go from 2 bodies to 3 bodies, top jaw over here, and that is because, once again, once 2 bodies are no longer connected, then it creates a new body automatically when you're in the part file. So always keep an eye in the solid bodies folder up here as you're using master part modeling. So then another cut, which created this one over here, the bottom jaw. And to be specific, let's look at this cut. I had 1 body in green, and by doing this cut, I now have 2 bodies because they're no longer connected. And when they're not connected, it automatically creates a new body in the part file. So you should start seeing a pattern here. And lastly, some holes that I made. So now we have 4 bodies. Now that you have these 4 bodies, you are in a part file. So you cannot do some of the things that you can in assembly, such as putting mates and providing motion. So how do you do that? You got the object you wanted and you wanted to give it some motion. Well, what you do is you can do 2 things. You either do the save bodies command, and in this body command you can select all the files or the different parts you want as I'm hovering my mouse, and you can export them into your folder, and then you can create an assembly from those files. Or you can come up to each file and you can save the body independently. Although the save bodies command is very handy because you can save all bodies at the same time, I must warn you that when you do save bodies, I think it's one of the most difficult features to deal with in SOLIDWORKS because a lot of errors will come up, either with the file associativity, with the file names, the directory. There's a variety of issues that can arise when you do save bodies. So a workaround, that's the beautiful thing about SOLIDWORKS, you usually have a lot of workarounds, is you can actually save each body independently. And to do so, you simply right-click the body, insert to new part. So here's the body that we're going to save. We need to choose the name of the file and the directory. Always read what SOLIDWORKS shows you from top to bottom. Very simple. You go to the directory that you want, and since I already saved it here, to not interfere with the other ones, I'm going to call it second top handle. You may notice this will save as a part file. We save it and accept. So now we have a part file that we can import to an assembly, and we can give it motion. Then you follow up by opening an assembly file. You import all the parts that you want independently, as you've done many times before. For those of you who have taken the CSWA and CSWP, you simply import the parts, you give it the mates that you desire, and you achieve the motion that you want. And you can only achieve this motion in an assembly file. So as a recap, all the files were created in a master part model. I exported each file independently from the master part model to the directory, and then I uploaded or I imported those independent part files into the assembly file, mated them, and gave it the desired motion. So that, my friends, is how to do master part modeling. Now I can expand on this and make an entire video about that if you like. If this is of interest to you, send me a message on LinkedIn to Rafael Testai or leave a comment below and I can do that for you. Until next time.